is when it's for limits, actually. And the reason why we teach it after derivatives, that it falls in this unit, is only because you need derivatives to be able to do it. But when you go to do a limit, and you go to fill in the value, and the value makes the denominator 0, or the numerator and denominator 0, we can't do that, correct? You can't divide by 0. But what we've had when we did limits in the first unit is we would factor stuff or whatever, and then we would cancel off factors, and then the problem child would cancel off and we could carry on. But that doesn't always work. So let's look at this first one. Find the limit as x approaches 1. Of ln x over x minus 1. So, if I plug a 1 in right now, I have a 0 in my denominator. Okay? And if I plug a 1 in the numerator, ln of 1 is 0. So that's 0 over 0, which is a problem. I can't factor it or multiply by conjugate, do any of those things to get to cancel off, correct? So what Lepp realized is that what I can do, though, is I can find the derivative of the numerator and the derivative of the denominator and plug in the value, and I will end up with the actual limit. Now, if I do the derivative of the numerator and derivative of the denominator, and I still get 0 over 0, I just do the derivative again. So I'll just keep doing that until it actually doesn't result in 0 over 0. Okay? So we rewrite the limit, because we haven't filled it in. The limit as x approaches 1. What's the derivative of ln of x? What is it? 1 over x. So remember, whatever the heck's beside your ln goes in your denominator, and then ln e in the base, and the derivative on top. Ln e is just 1, though, so it goes away. So the derivative of ln of x, we put the x in the bottom, the derivative of that on the top. Now, a lot of people try and do quotient rule here. That's not what I want. I don't want the derivative of the whole fraction. You do the derivative of the numerator by itself, and derivative of the denominator by itself. Okay? So what's the derivative of x minus 1? 1. Now if I plug in the value, do I get 0 over 0? No. So now I can plug it in. I get 1 over 1 divided by 1, which equals 1. This is just 1. Okay, let's try this one. The limit, find the limit as x approaches 0 of tan x minus x, bless me, all over x cubed. So tan of 0 is what? Sine over cos. What is y at 0? 0 over x at 0? 1. So tan of 0 is 0 minus 0 is 0 over 0. So we've got problems, correct? So we're going to do the derivative of it. So we're going to get equals the limit as x goes to 0. What's the derivative of tan of x? Secant squared x. Minus 1. All over, what's the derivative of x cubed? 3x squared. Now what if I plug in a 0? I'm going to get a problem again, correct? So what do I have to do? The derivative again. Now you have to watch yourself when you have the secant squared, because secant squared is lovely like this, but it's hard to find the derivative of it when it's like that. So how else can we write it? Secant x all squared. So you actually have to do chain rule with it, right? Whenever you got squared in the trig function, you have to rewrite it with the squared outside and then do chain rule. So what's the derivative of secant x all squared? 2, drop that in front, rewrite the inside, secant x to the 1 technically. What's the derivative of secant x? Yeah, secant x tan x. And now people might be like, well, that's a problem because it was a problem before. It was a problem before because secant x squared is 1. 1 minus 1 is 0, right? But the 1 went away now, so that problem is out. And then here I would have 6x. So now I have the limit as x goes to 0 of 2 secant squared x tan x, if you so choose, over 6x. So, what do we plug it in now? We just can't have 0 over 0, correct? So, can we split it though? Could we go again? Could we go again? Would it get rid of the problem on the bottom if we went again? Because you would get 6, right? How are we going to do the derivative of this though? What kind of derivative do we have to do? Two things multiplied. Product rule. So it equals a limit as x goes to 0. G, which is tan x. What's f prime? For secant x, right, to the 1, and then secant x tan x. Plus, so g f prime plus f, g prime. What's the derivative of tan x? Secant squared x. All over 6. Okay. Fill it in, see what you get. Here we're going to get the limit. And these we could factor, x plus 1, x minus 1, x minus 1. You know, we could do the old way. But we can still do L'Hopital. So we get 2x over 2x minus 1, which gets me 2 times 1 over 2 times 1 minus 1, which is 2. This one, what is the derivative of e to the 2t? What is it? Rewrite it. Ln the base, ln e, which I don't have to do, times derivative of the exponent, all over what's derivative of sine? Cos. So we're going to get e to the 2 times 0 times 2, cos of 2, cos of 2, cos of 0. What's anything to the power of 0? 1. 2 times 1 is 2. What's cos of 0? 1. Cos of 2.
Yes.